So let's now talk about seismograph. So what is seismograph? It is a device to record the seismic waves produced by earthquakes on the Earth's surface. Now, whenever an earthquake takes place, what happens? There's a lot of movement which takes place on the earth plates. Now, when a movement happens on earth plates, there's a lot of movement on the surface of earth as well. So these movements are recorded and a wave pattern is obtained. And the wave patterns are called seismic waves. So anything associated with earthquakes, there the term seismo is used for that. For example, seismograph, seismic waves, seismic zones. So this word is used for that. So due to the movement of the earth, waves which are produced, those waves are called seismic waves, and we make a note of those waves. And by looking at those waves, we find the amplitude of the waves. Now, by now, you all know what is the amplitude of a wave. So, once you know the amplitude, with that, you can get the values on the y axis of the Richter scale. So, let's see how exactly a seismograph looks like and how it works. So, this is a seismograph. Now, what is the aim of having a seismograph? The purpose is to accurately measure the motion of the ground. Whatever motion is taking place on the Earth's surface, so we have to accurately measure that motion. Now, during an earthquake, tall buildings, bridges, everything starts shaking. So, from where should we connect the seismograph so that accurate measurement of the ground motion can be taken? So seismograph are always connected to the bedrocks because bedrocks are comparatively more stable. So they are just moving from one place to another because if we connect to buildings or something, they are going to collapse. They are going to end. So our seismograph will not get a better value. So we connect the seismograph to the bedrocks. But at the same time, we do not want the instrument itself to shake a lot. Because if the seismograph itself is shaking too much, then again the accuracy of the measurement will not be that great. So, in order to make sure that the instrument is heavy enough to remain stable, what do? We hang a lot of weight from a rope. So, if you look at the construction of seismograph, you see there's a string, there's a strong support here, and from this support, there's a string, and to which is hung a pendulum bob. So, this is basically a weight just to give some weight to seismograph so that it's stable enough, so that it doesn't shake a lot during an earthquake. Now, to this and pendulum bob is attached a pen. Here, this is a pen, and to this pen is attached a paper. Now, what happens is as this bob moves, now whenever the earth is making movement, uh, so this pendulum, since it's hanging freely, so it will vibrate, right? As it vibrates, the pen is going to write down on the paper. So we are going to get the pen writing on the paper due to the movement of the pendulum bob, right? Now this paper is present uh, on a rotating drum, as you can see here. So this rotating drum will continuously keep on rotating. So the new paper will continuously keep on coming in. So at the end of it, what we will get a long sheet of paper with these kind of images being drawn by the pen. And how are these waves drawn? Due to the movement of the pendulum bob. Now, all that we need to do in a seismograph is a heavy weight in the form of a pendulum bob is kept so that the seismograph itself is comparatively stable. So, with all this, now we can actually get the pattern of seismic wave. And looking at that wave, you can actually amplify the waves to find out the amplitude. And this is used to give the value of the y-axis on the Richter side, Richter scale. Now, once you have the value, you can get the value on x-axis. And uh, when you get the value on x-axis, because they are nothing but log to the base 10, right? Log to the base 10 of the value on y-axis. So that's how you can actually calculate the magnitude of an earthquake. So whenever an earthquake takes place, seismograph will give you the seismic wave. From seismic wave, you will get the amplitude, and once you get the amplitude, you will be able to calculate the x-axis on the Richter scale. Now in Richter scale, if you see, it clearly tells you what magnitude of earthquake is actually dangerous. Do you see, as long as the value is 3 or less than 3, it's very minor, which is not felt. When it gets to 5 or 6, it's moderate earthquake, which is felt, but it doesn't cause any destruction. But as the value goes beyond 7, so the intensity of earthquake increases. The destructive power of earthquake also increase, and it can cause huge loss of life as well as property. Basically, this is how we measure earthquake. Now, let's look at some simple but important calculations associated with the Richter scale. Now, often people feel that okay, an earthquake of a magnitude 2 or a magnitude 3, that doesn't make much difference. It's just increased by 1 unit. But when the magnitude increases by 1 unit, the effect of that earthquake increases by several times. That is because this is a logarithmic scale. Now, whatever value is there on y-axis represent the amplitude. Now, we know that a Richter scale is based on the log to the base 10. That means the value of x-axis, that is Richter magnitude. Let's denote that Richter magnitude by r. So r is going to be equal to the log to the base 10 of value on the y-axis. Let's call the value of y-axis as y. Here we have written the value of y-axis in capital Y. Now let's say the value is represented by this y, and so as per the laws of logarithm, what we can say, y will be equal to 10 to the power of r, right? That is the relation between a value on the y-axis and the respective value on the x-axis. So the x-axis, so the x-axis value is considered as Richter magnitude as r here. So that means if we say that an earthquake is of magnitude 0 on Richter scale, so this would imply 10 to the power of 0, and which is equal to 1. Anything raised to the power of 0 is equivalent to 1. That is the value of y. Here value of y is 1. So the value of amplitude is 1. Now a Richter scale of 1. If we are having the Richter value of 1, what does it mean? It would mean 10 to the power of 1. So that means 10. Again, if we have the Richter scale of 2, that means 10 to the power of 2. That is, which is equal to 100. A Richter scale of 3 means 10 to the power of 3, which is 1000. So do you see something here? Now, as the value of the Richter scale, Richter magnitude increases, here Richter scale increases from 0 to 1, 1 to 2, then 2 to 3. So it also, here it just increases by 1 unit on the Richter scale. But just look at the increase on the y-axis. On the y-axis, it's increases very huge. See, it's increased from 1 to 10, then 10 to 100, then 100 to 1000, right? So increase on y-axis is huge when compared to the increase on the x-axis, correct? So that ways, say that here the difference between the destructive capacity of earthquake of magnitude 4 and of magnitude 6 is huge. It's not just by 1 unit or by 2 units. The difference is very huge. Difference goes up to 10 to power 3 times, 1000 times difference just for 2 units. So that ways, even a difference of 1 unit on the Richter scale then actually make a huge difference associated with the energy of that particular earthquake. So even though R increases by 1 unit, but the amplitude increases by 10 times, and that is important. So now that we have understood the cause of earthquake, now we also know the fault zones, right? So there are certain things that we can do just to handle an earthquake a little better, because we cannot do anything foolproof for the protection against earthquake, because earthquakes cannot be predicted, right? So what we can do to to give the protection against earthquake is to, and we can have the proper design of buildings and fault zones. At least we know the fault zones. For example, in India we know that northern part of country like Jammu and Kashmir, Northeast, Rajasthan, they are more prone to earthquakes. So the buildings can be designed in such a way that they do not collide or collapse during an earthquake. So how can we ensure that, right? So we can have by using light roofs. So roofs should be lighter so that even if the building collapse, the damage caused by the lighter roofs will be less as compared to heavier roofs. Fixed cupboards and furniture. So if you have like separate almirahs and cupboards, what happens when the building collapse? All the furniture also collapse, and they also fall on somebody and cause harm and injury. So when you have everything fixed on wall, the chances of stuffs falling over somebody also reduced. Well equipped to handle fire, because during an earthquake, since everything gets messed up, so the chances of catching fire in a building also increases. So proper equipment to handle fire should be present. Avoid hanging heavy objects. Like for a decoration purpose, we often use wall decors or clocks on the wall. So we should avoid using heavy objects, because during an earthquake, those objects might fall and they might injure somebody. So these are some of the small things which can be taken care in the fall zones. Stay away from tall objects during an earthquake, because the tall objects are more prone to earthquakes, are more prone to fall down, and when they fall they will fall on somebody, and if you stay near the tall objects your chances of getting injured will increase. Therefore it's always better to stay away, to stay in an open area with no buildings or offices nearby. So these are just few of the things which can be done to protect yourself and to protect the property against earthquakes. Thank you.